Hello, dear young minds. Welcome to PhysicsPoint. Here we are with the motion second video, and the main thing about this video is we're looking at the concept of distance and displacement. Very interesting topic and very useful topic for your higher classes also. All right, look at this. We have two words. One is distance, and another one is displacement. Okay, first of all, let me tell you the symbol for distance. Usually we use d, and for displacement we use s. All right, first and foremost thing is distance is a scalar quantity. What is this? This is a scalar quantity. Now you must be wondering what is this scalar quantity. Don't worry, I will come to that also. Displacement is a vector quantity. Scalar quantity and vector quantity, I will explain you what is the meaning of scalar quantity and vector quantity as the class proceeds. All right, so this is the first difference between this distance and displacement. Now the major thing in a distance and displacement, what we need to see here is, for example, I have point A and I have point B here. Now from point A to point B, how can you go? You can go in different ways, right? First way can be like this. Look at this. You can go, from point A to point B like this, or you may go like this also. You may go straight. All right, you may go straight A to B, or you may take this path also. You may go from A to B like this also. Let me name this path as first path, and this one as a second path, and this one as third path. All right, now look at this. This first path, don't you think it is lengthy? It is length, no? Length of the path covered. See how much path you are going. So this length of the path covered. And this second one, you have a look at this. This is also length of the path covered. All right, so this 1 and 2 whatever are there, no, so this 1 and 2 are distances. Now how about this third one? Don't you think from A to B this is the shortest distance? Whatever this third distance is there, this is the shortest distance. This is known as displacement. All right, so this point A is there, no, this point A is also known as initial point. What is this? Initial point, or you can call it as initial position also. There is no issue with that, initial position. And whatever this B is there, no, so this B is known as final point, or it is also known as final position. So that is easily understood. Now this will be the shortest. Anyway, you are going by first path or second path or third path, anyhow you are reaching the point B only, so that is a final position. So this shortest distance between this initial point and final point, whatever it is there, no, so this is known as what? Displacement. All right, so I have written a distance on left side, no, so all this 1 2 3, all of them are distances. So this first one, second one, first one, second one, and third one, all these are distances. But how about displacement? Displacement is only third one. Let me write that, only third one is displacement. See, left side it is a distance and right side it is displacement. Okay, this is continuing. Now distance means, you can just say in a simple words, total length of the path covered. What is this? Total length of the path covered is called distance. Total length of the path covered is called distance. Please take out your pen and notebook and start to make notes. Okay, now what is this displacement? Displacement is the shortest distance from initial point to final point. So whatever it is there, so that is known as displacement. I hope the concept is quite clear. You have to look for the initial point and you have to look for the final point, and whatever is the shortest, here is the shortest one, no, so that's what you need to look for, displacement. And 1 and 2 as usual, they are distances. All right, this is quite clear. Now let me ask you one question. This kind of questions are very common in all these competitive exams. Tick the correct one, tick the correct option. Okay, tick the correct option. So for example, the first option is like distance is greater than displacement. Let me write a DISP for displacement. All right, and second option is distance is greater than or equal to displacement, and third one is distance is equal to displacement. Distance is equal to displacement, and fourth option is let me give it as distance is less than displacement. Which one will you take? Just think about it. Now look at this. Whatever this distance is there, no, look at this. First is also distance, second is also distance, third is also distance. So don't you think distance will be always larger? So whatever this distance is there, no, so this will be always large, no. Okay, and the displacement is always less. Look at this. If you compare this first path, second path, and third path, always you will find out that displacement is shorter path. Correct? No, displacement will be always less. It may be equal also. If you take this third one, no, so whatever this third one is there, so this is distance also, and this is displacement also. It is an example for both distance as well as displacement. So that's why whatever this distance is there, that distance can be greater than displacement, or it can be equal also. Correct? No, is there any option like that? Here is the option. Look at this. Distance is greater than displacement, this is fine, but it may be equal also. So that's why we have gone for second option. And this one may be correct, may not be correct. Always it is not correct. And distance is less than displacement, it is not at all correct. And this is partially correct, this one. And this one is 100% correct. That is, distance is greater than or equal to displacement. All right, there can be one more question. So what is this? For example, whatever distance divided by displacement is there. Distance divided by displacement is there means this value is always greater than or equal to 1. Okay, this is very, very important information I'm giving you here. Why? Because this distance is always more or equal to displacement, no? More or equal to displacement. Here is displacement, already this displacement is here. If distance also becomes equal to displacement, means this value will become equal to 1. But I told you distance can be more also. Okay, if it is more, means a distance divided by displacement, it becomes greater than 1. So that's why distance divided by displacement is always greater than or equal to 1. Very, very important information. Similarly, if I ask you what is the value of displacement divided by distance, displacement divided by distance, it is quite reverse of that, that is less than or equal to 1. All right, so these things usually you won't find in your NCERT 9th standard textbook, but the concepts what I'm teaching right now, so these are going to be very, very useful for you in the future classes also, because in your competition, national level competitions, where the questions come from, you never know. So that's why it is better to have complete idea. All right, so distance and displacement concept is understood. Now I told you scalar and vector, no? Scalar, distance is a scalar quantity, and displacement is a vector quantity. Anyway, I will come to that in the later stage. Let us take some of the cases. Let us take a first case here. For example, a person started from one point, and he reached back to the same point, for example, in the form of a circle. Okay, he started from this point, for example, point A, and he ran in the form of a circle, in the ground, and he came back to the same point. Okay, now whatever circle he is revolving around, let us have this radius as r. Now tell me, what is the distance covered by this boy? What is the distance covered? It's quite simple, no? He took one round. Look at this, from A he took one round and came back to the same point. Means, what is the circumference of the circle? What is the length covered by him? It is a circumference, no? Don't you think circumference is 2 pi r? So that's what distance is, 2 pi r. Now how about displacement? Displacement means you have to look for the definition. It is the shortest distance from initial point. This is the initial point, and this is the final point. Both are same. That's why displacement is 0. All right, so first case is understood very easily. Let's take second case. Let's have a look at second case. For example, a boy started from one point, and he went in the form of a semicircle. For example, okay, let me show it normally here, in the form of a semicircle which is having radius r. For example, this is a small r. Okay, this is center. In the form of a semicircle, he went like this. He started from this point A, he went, he took one semicircular round, and he stopped here. Okay, now tell me, what is the distance? What is the distance here? Distance is, this length of the path. What is this length? This is semicircular, no? Semicircular means, don't you think it becomes, full circle means 2 pi r, and half of that means divided by 2. 2 get cancelled, and it is pi r. Okay, circumference of the semicircle is pi r. So this is a distance. Now, how about displacement? Please tell me about the displacement. Now, this is the initial position, and here is the final position. Now from this point A to B, what is this distance? Don't you think this is r? This distance is r, and this distance is again r. R plus r, don't you think it becomes 2r? So that's why displacement is going to be r plus r, or you can directly write the displacement is going to be 2r. All right, here 1r and here another r, that is r plus r is 2r. This is a displacement. All right, I hope you guys are understanding what I'm trying to say. Let us take one more case, third case. Now what he did, this boy started from this point. Okay, this boy started from this point O, and he went in the form of a straight line of 7 centimeter, for example, 7 centimeter. Then he took one not complete turn, a semicircular turn like this, and he stopped. He started from O and he stopped at, he went to A. Then he took turn here, semicircular turn here, and he came back and stopped at B. All right, now tell me, what is the distance? What is the value of distance? Okay, what is the distance? It's quite a simple case, no? O to A, he has covered how many centimeter? 7 centimeters. So in distance, you have to add that 7 plus. Then after that, from A to B, it is in the form of a semicircle. Semicircle means the circumference is pi r. So I'm going to write it as pi into r. So that is like 7 plus pi means 22 by 7, and r is radius is 7 centimeter. We know that 7 get cancelled, and 7 plus 22 is 29. So the distance traveled by that boy is going to be 29 meter. So this is quite simple. Now, if we come to displacement, what will be the value of displacement? Tell me. This is the initial position. Now, what is the final position? He went here, I know that, and he took the turn and he came back here. This is the final point, no? Look at this. This O is initial position, and this B is final position. Now, whatever this is there, no? This distance, whatever this OB is there, this is the displacement. All right, so displacement is nothing but OB. Now what is the value of that OB? If this is a 7 centimeter, means this is also 7 centimeter. So that's why displacement is going to be 7 centimeter. All right, so this is how you need to look for distance and displacement. Let us take one more case. Let us take a fourth case also here, so that you become quite aware about these things. For example, a boy started from one point here, this is point A. All right, what he did, he took 1/4 of circle. 1/4 means, you understand, no? 1/4 of circle. 1/4 of circle. Half of circle means, you understand, 1/4 means this much distance. This is 1/4, and if you go here, this is half, and this is 3/4, and it is complete. So you know about that. So he went for 1/4. All right, so this is the point O here, this is the point O here, and this is the point B here. Okay, from A to B he has come, and this radius is let us take this radius as r, and this also as r, and definitely this is 90 degree. Now they are asking distance. What is the distance they are asking? Now distance is quite simple, no? If it is a complete circle, means, if it is complete circle means, how much it would have been? It would have been 2 pi r. All right, distance would have been 2 pi r. But how much distance this boy has covered? How much length this boy has covered? This boy has covered only 1/4 distance. All right, so that is like 2 ones are 2 twos are. So distance become pi r divided by 2. Okay, otherwise you can think like semicircle means, what is this total length? For example, from this point to this point, semicircular means it is pi r. All right, and half of that means pi r divided by 2. You can think like that also. There is no issue with that. Now the major thing is, what is the displacement? What is the displacement? All right, now look at this. As per the definition of displacement, this is the initial position, and this is the final position. Now whatever the shortest distance, now you cannot consider this becomes little lengthy, right? Shortest distance means you have to take a straight line. So whatever I'm getting here, so this will be the displacement. Now the big question is how to get this. Now you have one beautiful theorem called Pythagoras theorem. This is 90-degree. All right, so this is AOB is a right angle triangle. So whatever this displacement is there, so that displacement is nothing but AB. All right, now how to get the value of AB? You know Pythagoras theorem, no? So what is that Pythagoras theorem? Says AB square is equal to AO square plus BO square. Look at this, AO square, this is not AO, AB, this is hypotenuse, right? This AB square is equal to AO square plus BO square. All right, so AO and BO both are radius, so that is like R square plus R square. R square plus R square is 2R square, and AB square is there. So I don't want AB square, we want only AB. So AB is equal to under root 2R square. All right, so AB is equal to root 2 remains as usual, and it can be written as under root R square also. You have learned all these fundamentals in number system chapter. This square and square root get cancelled, and afterwards AB will become root 2 R units. Okay, there is nothing like centimeter and all here, so that's why just some units. All right, so this is also pi r by 2 units. So displacement, whatever this AB is there, it is going to be root 2 r units. All right, I hope the things are becoming quite clear. Let us take one more case to check whether you have understood this concept or not. All right, for example, there is a wheel. Okay, there is a wheel like this. There is a wheel, and definitely wheel means it must be having some radius, no? So this radius is like r. All right, here is a point P. Here we have mentioned one point P here. Let me mark it with red color. This is the point P. All right, now what this wheel does, this wheel does half rotation. Okay, it does half rotation, and it comes here. Okay, it comes here after doing the half rotation. Now they are asking one simple question. The question is find displacement of point P. Have you understood the situation? What is this? Here is a wheel. All right, here is a wheel of radius r. In that there is a point called P. This does half rotation, and the wheel is here now. Now they're asking what is the displacement of this point P. Displacement definition, you know. What is the definition of the displacement? It is a distance between them. It is the shortest distance between the initial point and final point. Now where it will reach, just check that. Okay, for example, I mean, this does a half rotation. Half rotation means, you understand, no? Half rotation means it will come above here, somewhere here. If it does full rotation means where this point P would have come, it would have come back to the same point here only. After full rotation, it would have come back to the same point. But it has done half rotation means exactly opposite it will go here, no? So let me mark that point as P dash. Okay, now what is this P? So whatever this P is there, this is the initial position, and whatever this P dash is there, this is the final position. Now between them, whatever this distance is there, no? This distance, blue color P dash is there, oh, this is the displacement. All right, so now you need to find out the value of P dash. Now big challenge is how to find this P dash. Now you have to use your brains here. Now from this point P, if it has covered half rotation means, full rotation means it would have covered how much distance? 2 pi r, no? Because it is touching the ground, whatever this ground is there, no? This ground level is there, so it is touching the ground and it is going. If it is doing a half rotation means, don't you think from this point P till here, so this is like half of 2 pi r. I mean, full means 2 pi r, half means divided by 2 to get cancelled. Don't you think it is pi r? So whatever this distance is there from P to let me name this point as A. Whatever this PA is there, so this is going to be pi r. This value is pi r. All right, now how about this P dash to A? What is this distance? This is a radius, no? I mean, radius is same everywhere. Here also r, here also r. So that's why, don't you think it becomes 2r? All right, so here it is. So whatever this distance I am showing here, so this distance is pi r and this distance is 2r, and definitely this is a 90 degree here. Now again you can apply Pythagoras theorem, because this whatever this p dash is there, this is the hypotenuse. All right, I hope the concept is quite clear now. So that's why displacement equal to, I will write displacement is equal to p dash. All right, displacement is p dash from point P to P dash. This is the displacement, and we need to find it out. All right, so I mean, how to do that? So that is like p dash whole square, p dash whole square is equal to pa square plus, and what is other thing, p dash a whole square, p dash a whole square. All right, what is pa? What is the value of pa? Pa means pi r, already I have told that. So what is that? That becomes pi r whole square plus what is p dash a? Look at this, p dash a is 2r, so that is like 2r whole square. So it becomes I mean pi square r square plus 4r square. All right, so you can take r square common. If you take r square common, so what remains here? Pi square plus 4. All right, so this is p dash whole square. So p dash is equal to under root r square bracket pi square plus 4. All right, so p dash is equal to under root r square means, so you can write it as r under root pi square plus 4. All right, so this is the value of displacement. So p dash, so that is equal to r under root pi square plus 4 units. Definitely units will be there. There is no denying in that. So this is the value of displacement. So this fifth problem was a very standard, and I think it has come in NTSC and some of the competitive exams also many of the times. So you can have a look at that. All right, so I hope the concept of distance and displacement is quite clear to you. Distance is a scalar quantity. The video is getting lengthy. Usually we are making video very short videos up to 25 minutes only, so that you understand all the concepts. So in the next video I'll be explaining you what is the meaning of scalar quantity and vector quantity and how we have to make use of them along with the displacement. No, so whatever displacement we have mentioned, we have to mention some direction also here. There will be some direction. Okay, what is the concept? 7 centimeter is there, no? So some direction we have to mention. Wherever displacement is there, some direction has to come. So what is the concept of that direction? That will come under vectors concept. All right, so this is more than enough, and a lot of detailing I have given. All right, definitely you must be enjoying all these videos. If you're enjoying all these videos and if you're getting benefited from them, like these videos and share them with your friends. All right, don't forget to comment down. Sometimes I'll be asking questions also, and whatever you want to listen from us, comment down below. And don't forget to subscribe to the channel, because your subscription gives us a lot of support to make all these videos. Thank you very much. Have a good day, and bye bye.